to MathRock's channel. In this video, you will learn about the arithmetic series, specifically the definition of the arithmetic series, as well as how we derive a formula for the arithmetic series. Arithmetic series. So let us start with the definition of the arithmetic series. So the arithmetic series is the sum of the first indicated number of terms in an arithmetic sequence. And to further understand the concept of this definition of the arithmetic series, let us try to consider this problem. So the problem asks how many matchsticks were used altogether to make the figures. So here, you will notice that the figure is separated into 5 smaller figures, like the figure here, the other one here, and the 3 other figures as shown. So let us try to consider the number of matchsticks used per figure. And let us start with this one. So here we can easily count that we have a total of 1, 2, 3 matchsticks. So let us write the number for the meantime. So here we have used 3 matchsticks to come up with this illustration. And on the other figure, you will notice that this figure right here is the exact figure here. So since we have already counted that we need 3 sticks to come up with such figure, then we only need to count the additional number of matchsticks. So here we have an additional of 1 and 2. So let me just write a short note here that we merely need to add 2 more matchsticks to come up with the total of matchsticks used for this specific figure. And going on to the next figure, again, you will notice that this exact figure right here is the same with the previous one. And we have already counted that we have, yes, a total of 5, but I would like the 5 be written as it is, like this. And now, to come up with the total number of matchsticks used for this specific figure, we merely have to count for the additional matchsticks. And we have 1 and 2. So let us try to write that we only need to have 2 additional matchsticks for this figure. And as of now, you would have noticed that the concept that governs such idea is the same with the concept of arithmetic sequence, for which we are only adding a fixed number. In this case, we are adding 2 to come up with the number of matchsticks used for the next figure. And let us try if we can obtain the correct number of matchsticks used for the next figure by doing the same idea. So with that, you will notice that this exact figure right here is exactly the same with this one. So that means we have a total of 7 matchsticks here, written as 3 plus 2 and plus another 2. And here, you will notice that we need another 2 matchsticks to come up with the total of number of matchsticks used for this specific figure. So that means we have justified that this is really just a concept of arithmetic series. So that for the next one, we can easily make a conclusion that the number of matchsticks used for this specific figure is 3 plus 2 plus 2 plus 2 and another 2 right here. So now let us have the number of matchsticks used for each figure. For the first one, we have A3. So writing A3 right here. So next, we have 3 plus 2, which has a total of 5. While this one, we have A5, adding another 2 gives us 7. While here, we have this, equal to 7, plus another 2, we have the 9. So the next would be 11. So you will notice that this set of numbers form the concept of arithmetic sequence. Now, if we would like to have the total number of matchsticks, then it requires us to have all these numbers be added. So notice that when these numbers forming an arithmetic sequence is being added, then we are now forming the concept of the arithmetic series. So again, if we would like to add the terms in the arithmetic sequence, then the concept becomes an arithmetic series. And now for our answer, we have a total of 35 matchsticks. And let us proceed with the next part of this video. So, what if we do not wish to manually count for the total number of matchsticks used? So, especially when we try to increase the number of triangles in the figure. So, counting would obviously be not the most convenient way to come up with an answer. So that means we must have a special way to come up with an answer even though we do not have to manually count for the total number of matchsticks. So therefore, we need to have a formula. So let us start with the way how we write an arithmetic series. So normally an arithmetic series is denoted by a capital letter S followed by a subscript n. So the n suggests the number of terms in the arithmetic sequence being added in the series. Like for example, here, since we have 5 numbers and we wish to add these 5 numbers in the sequence, then it will have a value of 5. So writing S sub 5 for this specific problem. So since our goal is to derive a formula for this, then the process for which we can derive the formula for the series is to have another set of the same numbers from 3 going to 11, but this time we should have this be written backwards. So having the 11 first, followed by 9, 7, 5, and last we have the 3. So since we are referring to the series of these 5 terms in the arithmetic sequence, then it requires us to add all these numbers as well. And we will not have the addition of the numbers horizontally like this, but instead we would like to have the addition process vertically, like having the addition of the 3 and the 11 first, followed by 5 and 9, 7 and 7, and so on. So doing so, you will notice a certain pattern here. Okay, and such pattern actually gives us the same sum of 14 for each of those pair of numbers. So with that in mind, we must do the same on the left-hand side of this equal sign. Doing so, we have S sub 5 being added to another S sub 5, giving us 2S sub 5. So you just have to consider your S sub 5 as a variable and proceed adding this to. The same as how you add variables like x plus x equals 2x. And now, let us proceed with the addition of all of the same numbers, 14. And since you have learned in your elementary lessons that adding same numbers like this is the actual concept of multiplication, then we can rewrite such expression in multiplication like adding 1, 2, 3, 4, 5 14s, then it would be 5 times 14 in multiplication. So here, since our goal is to come up with the sum of the first 5 terms of the arithmetic sequence, not 2 of this series of 5. Therefore, we must eliminate the 2 on the left-hand side of the equal sign. Doing so, we can apply the multiplication property of equality. But there is also a property that states that we can divide a certain number to one side of the equal sign, and doing the same on the other side of the equal sign doesn't necessarily affect the equality between the two sides of the equal sign, and that is the division property of equality. Doing so, we have to divide both sides of this equal sign by 2. So it eliminates the 2 on the left-hand side of the equal sign, isolating only the sum of the first 5 terms, which is our primary goal for this. And now, let us try to have each of the numbers that we see here be expressed in terms of general terms. So let's say the S sub 5 would now be S sub n, changing the 5 to n. So the purpose for that is the n usually denotes the number of terms being added in the sequence. Since in our problem, we would like to have this 5 terms in the sequence be added, therefore your n represents the number of terms 5. So that will be the reason why we would like to have this 5 be expressed as the n. We will do the same for the other 5 right here, so your 5 would now be n. So with regards to the 14, so the 14 is based upon the idea of the numbers being added to come up with such number 14. And if we would like to make use of the first pair of numbers here, 3 and 11, so let me write first 3 plus 11, then you will notice that the 3 is the first term of the original sequence, and we have learned in your previous lesson that the first term is usually written as a sub 1, while the 11 originally is the fifth term of this sequence. So writing the fifth term as a sub 5, since we have already changed the 5 in terms of this subscript n, therefore your 5 here also changes to n. So with that, we may now have this be written as a sub n instead. So the other 14s here, particularly the pair of numbers being added to come up with such number 14, will also be reduced to that same expression. And writing the a sub 1 plus the a sub n in here by dividing this expression by 2 as shown in our previous equation, then we will have this equation to be one of our formulas for the arithmetic sequence. And now for the other formula, it is only based upon the idea of the a sub n being written in terms of the expression that gives us the formula for the nth term. So going back to such formula, we have our a sub n be equal to a sub 1 plus the quantity of n minus 1 times 3. So we merely have to apply the substitution property, changing the a sub n in this formula to this expression. Doing so, we have our s sub n be equal to n times the quantity of a sub 1. So this time, we would like to have the a sub n be equal to this expression. Doing so, we have a sub 1 plus the quantity of n minus 1 times d. So anyway, let me change this to this first. So the other part of the formula is d over 2. So now the only procedure left is to simplify the resulting equation. Doing so, we have s sub n be equal to n, and combining this similar terms gives us 2a sub 1. So writing the remaining parts of this equation, we have this. So having the second formula. So this would be our other formula for the arithmetic series. So to summarize the important ideas of this video, so we have the arithmetic series in general. So an arithmetic series is denoted by the s sub n, which is equal to a sub 1 plus a sub 2 plus a sub 3, and so on until we have the nth term of the formula. Whereas the s sub n is usually given by two formulas, having this as the first one. The s sub n is equal to the n times the quantity of a sub 1 plus the a sub n over 2. While the other formula is the s sub n, which is equal to n times the quantity of 2 a sub 1 plus the quantity of n minus 1 times the all over 2.